Sup y'all, it's your boy Bevan. So this video is gonna be like a technical breakdown of the Claymore video that I made the other day. This video is gonna recap like the CAD process as well as the slicing process, and also probably a little bit of a design consideration and what to use, why I use this, why I use that, because you know this technical stuff would just take too long to explain in the other video. Now first things first, before drawing your model, you'd want to find yourself like a pretty decent reference. You're just gonna want to scroll on to Google and then search for a picture that's like relatively flat, in which the weapon you're trying to replicate is not like angled or some shit, because this is gonna make the process like way easier in the CAD. Now you'd want to save that file, start Fusion, and then hit this insert button right here so you can put that image we just downloaded as a canvas. So canvas here is basically just like a semi-transparent image here that you could like use to map out your lines, just so that you don't have to like eyeball too much of it. Once that's done, we want to calibrate the canvas by hitting these 2 points and then typing at the specified length we want. For me it would be 1.5 meters, so it would be like 1500 millimeters, something like that. And yeah, at this point we're basically ready to start drawing. Now if we take a quick glance of the sword design, there's actually not much to it. As you can see, we can like split this sword into like 4 different parts: the blade, the handle, and the handguard, as well as this small engraving right here. So we basically only have like 4 major steps to do here. So first things first, let's just start with the blade. Now you want to hit sketch, and then we basically just want to like trace the outline of the sword. And this, guys, is where it gets pretty game breaking. Drag your mouse onto the sketch palette and then look for like the lowest option in the box that says 3D sketch, and now you click it. And then basically if you press here and then you rotate your image a little bit, and boom, holy shit, you guys see that? We're drawing on the 3rd axis, we're drawing on the z-axis. This is not doable on paper. This is why I call this shit Fusion 360 on hacks, you know what I'm saying? Now once with this 3D mode activated, we're gonna want to like draw a point at around 10 millimeter thickness on one side, and then basically just connect the remaining lines we can see here onto that point. And basically we already have like one side of the blade right now. Now all we have to do is just like finish sketch, go to the surface menu, then we select patch, and now we just basically like click on the lines that we just drew on the sketch, and we basically have like the surface on one side of the blade done already. We just gotta like hit mirror and copy the entire thing on the other side, go back to surface, hit stitch, select all of them, and boom, that's our blade done. Now let's move on to the handle. You're basically just gonna want to draw the outline of the handle, and then you might want to let it extend to the lingette a little bit, because that part is also cylindrical. Once you have like a sketch that looks like this, you just want to hit revolve, select the profile, and then select the mirror line so we can rotate it in that axis. The handguard uses the same logic and principle as the blade, so basically just like pop on that 3D sketch and then just follow along the lines, move some of the lines to a 3rd axis when necessary, and then use patch to cover everything up. Basically that leaves us with the last step, which is the engraving. You just want to like create a new sketch, draw all this engraving on one side, then mirror it on the other side. Now you're gonna want to leave that sketch, and then you're gonna want to use split body, select the blade to split, and then use that engraving sketch as your splitting tool. And then with that, you basically cut out the shape of the engraving. If you try to move this around, you basically have a cleanly cut hole and basically the content of that hole right here. And now you're going to want to scale that cut out engraving down. So grab scale and then choose like a point. Make sure it's somewhere on the middle and not like on top here, or else this is gonna like mess your scaling up. And select scale type to non-uniform, and basically adjust the wild scale to something like, I don't know, 0.7. Yeah, 0.7 sounds good, I guess. That's basically our Claymore done. Now we're just gonna wanna combine every single part, and we basically have one, so that we have basically one solid piece of Claymore. Now you're just gonna wanna select one body and then just like select the rest of the body, and boom. that's the model done right there. And now we're gonna be preparing our parts for 3D printing, because obviously we cannot fit like a 1.5 meter sword into like a small 3D printer like mine now, can we? So now we're gonna want to cut the sword into like smaller pieces that would actually fit in there. Now, as you all know, like the average printer is about like 15 to 30 centimeters long. Personally, my Ender 3 is about like 22 centimeters long and wide. But here's the thing. We can use Pythagoras theorem, and then we could like use the diagonal side of our bit and get more printing space that way. And so using that, I'm able to get like a 31 centimeter length max instead of the 22 centimeter, which honestly in my opinion is pretty damn significant, you know what I'm saying? And so I'd want to cut my parts at around 29 centimeters just to give it a little bit of a clearance. So I'm just gonna like draw a bunch of lines to use the split body on, and then cut the blade into the appropriate sizes. Now once we have like our blades cut out, let's think of how we're gonna put the blade together once we're done. Now if you've been following my channel for a long time, you probably knew like I used one of those small connector profiles that you would like put at the end of each section and then connect it to the other one. Well, that one's fine, but back when I made my Claymore video, this happened. Bruh. So honestly, I'm a little bit pessimistic that those small connectors are gonna hold out against this much weight, which is why we're gonna have to go with something stronger. So I was walking on Home Depot the other day and I stumbled upon some of these aluminum rods. Like, aluminum is more resilient compared to plastic, and so at least if the sword breaks, it's not gonna snap in half right off. It's just gonna like crack a little bit, and then it would probably be much more easier to fix. In short, the aluminum rod is gonna absorb the damage by a large amount. And so I'm just gonna like quickly draw a 6mm hole, and then use extrude to cut it about the length of 142 centimeters throughout the blade, creating a hole in each section so that we can connect the blade later on. And now once the model is done, we've already cut it into smaller pieces as well. Here's how we can transfer this model onto Cura so that we can prepare it for printing. So you scroll down to the Utilities tab, and then you hit this option 3D print, and then scroll down, uncheck that box, okay, and then basically you can just like save it wherever you want. Now once that's done, we can just like go start up Cura and start slicing. For those of you who don't know what slicing is, it's basically just like preparing your parts for printing. This is basically just like calculating the amount of material that goes in here, also like generating the commands of how your printer is going to be moving in order to create this part. So now we're just going to want to import the file and then rotate it around a bit, specifically diagonally, so it would fit our build plate, flatten it on the bit, and then just tweak with the settings a bit. Now, there's actually like not much to the settings. I'm just gonna like let this scroll down slowly on screen so you guys can copy it. So yeah, that's basically it. I think that's just all the technical stuff I need to explain about the Claymore. So I guess I'll just catch you up in my next project. Until then, say you live.